Hello everyone, welcome back to another lecture in digital electronics series. Today we are gonna learn about how to design a combinational circuit, and then we will learn about half adder, its truth table, and how we will design half adder using NAND gate and NOR gates only. So let us study. So what is a combinational circuit? First, a combinational circuit is nothing but a circuit that depends upon only upon the present inputs. So my output will vary only upon the present input. So if I am uh, so to design this type of circuit, all I need is first I need to know what are my inputs and how many inputs I am going to have and how many outputs I need to have. So this will be provided in design. So if you are asked to design a circuit, then they will provide these are my input line. These must be my inputs and these must be my outputs. They will specify this. So when based upon that, you will identify the input lines and output lines, and then after identifying the input lines and output lines, you will draw the truth table. We know if you are having two inputs, then we will have truth table for 2 power 2, that is 4 combination. So we will draw truth table for all the 2 power n combinations, and we will write what are the specific outputs for each combination. So then we will write form a truth table, and then we will, after drawing the truth table, we will write SOP or POS, and SOP means sum of products and POH product of sum. So we know we will write POS SOP for ones and POS for zeros, logic zeros, and SOP for logic ones. So after that, we need to simplify the equation that we are getting after we are writing in the SOP form. So in order to uh, simplify the logic function, then I need to use Boolean theorems or K maps, and then we will implement using logic gate. So this is how you design a combinational circuit. And now let us design a half adder circuit. And what is the first step in designing a combinational circuit? First we need to know what are the number of inputs and what are the number of output lines that I am having. So in a half adder is a combinational circuit that will add two variables and will give two outputs, and one will be sum and one will be carry. So my let us take my two input variables as one as a and one as b, and one will be sum, and that is represented with S, and carry with C. So what my half adder do is it will add these two variables, two input variables, the data in the two input variables, and give my output sum and carry. So let us see what will my half adder give. For 0 plus 0, it will give sum 0, carry 0. For 0 plus 1, it will give sum 1, carry 0. 1 plus 0, sum 1, carry 0. So here is 1 1. This is the most important in adder. In while solving equations, if we are having 1 plus 1, we will do 1, but and carry will be 1. So this is because, let us take an example. Let us take a, a decimal number. I am having 21 and 29. Then I will get, I am taking 0, and here I am taking 5. So this is because the decimal number has base 10. We know this, the decimal number has base 10. So this is, you can write as 21 10 plus 29 of 10. So whenever I am getting the highest value, I am taking my sum as 0, and I am taking carry as 1. So here also we are taking same. So for 2 power n, two input variables, my maximum number is 0 to 3. So if I am getting 3, then I will take 0 and 1. So that is how you will write the truth table of half adder. So now we will understand the design for half adder using NAND gates. So first we will write the output equation for this one. So what will be my output equation here? S of a comma b. We will write the SOP equation first. Summation of, and this is 0 and 1. Sorry, 0 1 2 3, right? 1 comma 2 is my SOP equation, and that is a bar b plus ab bar. We know that this is the XOR operation, and we will also write for carry C of a comma b, that is summation m of 3, and 3 means ab, product of two input variables. So this is how you will design a XOR half adder circuit. So let us I will implement using gates here. 1 second. These are my I'll just draw this one and I will connect this one. This is my input A and this is B and this is my sum. XOR is sum. The sum and this is carry. That is A XOR B. This is equal to A into B. So this is the half adder using logic gates. Now let us understand what is half adder using NAND gates here. So here I am having we know sum is A XOR B and my carry is AB. So my NAND output, we know that the output of NAND is A, B will be A into B bar for NAND. So based upon this, we in logic gates using NAND, I have explained this circuit will be, this is the circuit for XOR operation. So if you did not check this one, I will give the link in description as well as in iCard. Then you can check this video. So here I am having two input variables A and B. I am getting here AB bar and I am getting A and here I am getting B. So we know this will be A XOR B. So this will be my sum. So in order to get my output is AB, carry output. So in order to get AB, then I will simply take this one and I will join here. I am taking my AB bar as a AB bar and this will what will happen here, AB bar into AB bar whole bar, that will be AB bar plus AB bar, that will be AB plus AB will be AB. So this is how you will get half adder using NAND gate. Now let us so we can write, we need five NAND gates are required to implement half adder. So now let us learn about half adder using NOR gate. So if we follow the same method as a XOR operation, we will get more number of gates here for using NOR. So we will take another process here. What I will do is I will take these two inputs. I will short this one and this one. So what I will get here, I am giving my inputs A and B. Then this one I will have A bar and I will have B bar. So I will have here A bar plus B bar whole bar, that will give me A into B. So here I am getting my carry. So we know if I am getting AB, if I am giving A bar and B bar here, if I am giving A bar and B bar here, if I am giving this to this input, then I will get the I will get AB plus A bar B bar whole bar. So that will be XNOR complement of XNOR and that will be XOR. So what I will give is I will give here AB again. So I will get here A bar B bar. So this one will be my sum, that is equal to AB plus A bar B bar whole bar. Then you will get A, this one is A XNOR B complement. So this will be A XOR B. So this is how you will design using NOR gates. So this adders in next video we will learn about full adder. So until then stay tuned. Thank you.